Hello, in this lecture presented by www.free-academy.com, we're going to be doing our first of several practice problems on the derivative quotient rule. Now, the format's going to be similar to what we did with the product rule. We're going to do a few examples to demonstrate. Then after we do our lecture on the trigonometric derivatives, we're going to go back and we're going to expand on the product rule and the quotient rule. And this is just because, once you've seen the product rule or the quotient rule applied to polynomials, which is the only thing we know how to find the derivatives now, you only need to see a few examples before you become proficient in all the examples. So which is why we need to expand our vocabulary of derivatives a little bit more. But anyways, enough chitter chatter. To use the quotient rule, you're finding the derivatives of one function divided by another function. This could very easily be x squared divided by x plus 3, where you cannot obviously divide the denominator into numerator. You can using various techniques, partial fractions, things of that nature, but it's not usually convenient. So you'll call 1 is equal to f and 1 is equal to g. F will be equal to, in this example, x squared, and g will be equal to x plus 3. And then once you find f prime and g prime, you just simply plug everything into the quotient rule formula and you get the solution. So this is going to be the exact procedure we're going to use for all of these practice problems here. And we'll start out by doing an example with problem 21, in which case we have y equals 1 over 5x to minus third, and we need to find y prime. One thing I want to point out is we're using y instead of f of x and y prime instead of f prime of x. The notations are perfectly identical. Y prime you could also write as dy over dx. And you can find all these different things in our lecture on derivative notations. Now I feel like I got a little bit sidetracked in putting that out there. We have y equal 1 over 5x to the minus third. This is going to be equal to f divided by g, which is going to imply that f is equal to 1 and g is equal to 5x to the minus third. One thing that I like about quotient rule problems as opposed to product rule problems is what is f and what is g tends to be a lot more obvious. But however, one thing that isn't very nice is the formula is a little bit harder to remember. I like to use low d high minus high d low over low squared, and I covered what that means in my lecture. But that's saying that g is equal to low, f is equal to high, and d stands for the derivative. That little song I've used since I took calculus my junior year of high school. So we'll go on with solving the problems, and hopefully I'll stop getting off topic now. We have f is equal to 1, so f prime is going to be equal to 0 because the derivative of a constant is always equal to 0. We have g is equal to 5x minus 3, so g prime will be equal to 5, and this is just using our power rule. So with f prime, g prime, let's put everything into its appropriate place. Y prime is equal to g f prime minus f g prime divided by g squared. G is 5x minus 3 times f prime, which is 0. This is minus f, which is 1, times g prime, which is equal to 5. This is all divided by g squared, which is 5x to the minus 3 squared. 0 times 5x to the negative 3 is equal to 0. 1 times 5 is equal to negative 5, so this is going to be negative 5 divided by 5x to the minus 3 squared. The procedure is relatively simple. Assign something as f, something as g, find the derivatives of f and g, and then plug everything into the formula, and you have the derivative using the quotient rule. Let's go on and do another practice problem, and we'll do problem 22. 22, we have y equals 3 over the square root of x plus 2. This is going to be equal to f divided by g, which is going to imply that f is equal to 3, and that g is equal to the square root of x plus 2. F prime will be easy to find, that'll be 0 once again. G prime will be a little bit more complicated, because you need to remember the trick from our power rule lectures of rewriting the square root as a half. Once you remember that trick, you apply the power rule, you get 1/2 x to the minus 1/2. Derivative of 2 is equal to 0. Y prime is going to be equal to g f prime minus f g prime over g squared, as defined by our derivative rule, our quotient rule, sorry. So now, once we have these different pieces, it's just a matter of plugging and chugging. G is equal to square root of x plus 2. This is times f prime, which is equal to 0. So this is minus, f, which is 3, times g prime, which is 1/2 x to the negative 1/2, all divided by g squared, which is square root of x plus 2 squared. There isn't much to be done about simplifying this expression here. We can very quickly do it. This term, of course, is equal to 0 because it's multiplied by 0. We'll get minus 3. We'll take the 2x to the negative half to the bottom. So this is 2 square roots of x multiplied by the square root of x plus 2 squared. And there we have our first couple quotient rules problems. We'll do a few more onto trigs and then come back to this. So get all the help you need because we'll have it online. And if you have any questions, feel free to send them to us.